Okay, the previous video was a terrible thing, but at least show something. So we have actually done all this, alright, for the previous video, talking about composite failure and how to assess the failure and what are the equations used for the failure, and what are the definitions for max stress and Zai-Hugh, and when do you want to use them, and things like that. Especially the most important graph, which is that the maximum stress is this one and the Zai-Hugh stress is the one under all the maximum stress, alright, which is pretty cool. But anyway, so come back here as a factor of safety, which is the last part of our whole thing before we go into tutorial, is that it's the factor comes from where? Comes from ultimate strength divided by your working stress. Ultimate strength talks about the material, the strength of your material. The working stress talks about the stress acting on the material. Alright, so this is the input stress. Alright, so if I were to rearrange the thing so that it's easier to see, so if I were to bring the working stress upwards, I bring the factor down, I would have what? The working stress, the one that you want, I mean the input stress of is equals to the strength of a material divided by the factor. Alright, and that's all it is. Okay, so if you have this is the strength of a material. If you have a factor of 2, which is used for static short-term loop, alright, then you divide by 2 and you'll get something of the value. And ensure that this value is so-called larger, or larger, should be larger than your working stress. If it's smaller, alright, then you will fail. So I repeat again, your working stress must be smaller than this thing. Okay, must be smaller than this thing. Otherwise you will fail. Different conditions use different factors. Alright, this is from experimental results, I think. So for static means that you just put it there and let it go. Alright, for long term you put it for a long time. Alright, short term you put it a short time. Alright, fatigue loads means that you're gonna put it in a cyclic loading, meaning it's very dynamic. So you, for example, this is the spring, and then this is the thing. So your goes up and down, goes up and down, goes up and down. So different factors will require you to have different stuff. Okay. Therefore, how would you apply the above factors in the equations on failure criteria, on Zai-Hugh and max stress? For the different cases, for example, your isotropic, you use the von Mises, correct? If you don't understand anything, alright, right now, right here, you can go back to the previous video on 6.4. We'll talk about the different composite failures and things like that. So the first one was the isotropic material for von Mises. It's a shorter version one. Alright, so this thing over here is for this one, I believe. Alright, I may be wrong because it's coming from me myself only. Alright, so yeah, I may be wrong. So you take this thing divided by a certain factor, you ensure that it should be smaller than this thing. Otherwise you'll fail. Okay, so you take this thing and sub it in as your ultimate strength. Alright, as for this thing altogether, alright, your x is your strength, so you're gonna sub in as your ultimate strength, and your y and your s all you sub in. Alright, and then you divide the strength by the certain factor. For example, if this s strength is maybe 5, you divide it by, maybe the factor is 2, then you 5 divided by 2 is equals to 2.5. So your s with the factor is 2.5, and then you divide it by sine theta, cosine theta, you'll get certain thing. So ensure that this stresses is not larger than this, otherwise you'll fail. Okay, this is for the max stress theory. Okay, so same thing for your stresses over here, for your strength over here, x you just sub in as your ultimate strength, your s and your y is still your strength, because whenever you see x, capital X, y and s all are capital letter, this means you're talking about the strength of the material. So you just need to work it out to the factors, and then you should be able to calculate the things that you need. I also found a very good slide. Alright, you can go to the reading material and page 42. Alright, this is a summary of all the properties and equation for a unidirectional laminate. Or it's not isotropic, it's anisotropic. Okay, one direction only because it's unidirectional. Okay, and therefore over here it gives you all the Young modulus, how you calculate for your Young modulus. These are all your ratio, or this is your so-called, what's that called? Your volume, your ratio, your volume ratio, or volume ratio of your matrix, volume ratio of a fiber. With the curly V, this is your so-called your Poisson ratio and things like that. Everything is over here is pretty straightforward. Okay, and then over here this is the reduced stiffness matrix where it tells you all the stiffness. This is only for Q. If you think about it, we have a Qij. Alright, it's a transform. Alright, Q is for the stress X and stress 1 and 2, tau 1, 2. Alright, if you have Qij, this is actually for stress X, stress Y, and tau xy. Okay, so if you take a look, this is the thing for your stresses, but this thing over here, as you can see, is in terms of a strain 1 and 2. Alright, so you want to convert it. Alright, this Q is for 1 and 2 direction. So this is the X, this is the Y, and this is the 2, and this is the 1 direction, right? So the strain is still in terms of the 1, 2 direction, while the stress is in terms of X, Y. Alright, so that's why you need to convert, and this is why we have a Q bar. Alright, this is the Q bar. Where the Q bar itself, if you take a look, alright, this is the Q bar, and this one over here is the strain X and strain Y. So it straight away convert to the X and Y direction. You don't need to convert anymore because the equation is already straight away inside the transformation matrix. Alright, but likewise this thing over here, I don't know whether you need to I think you should memorize. Yeah, so also got stress and strain transformation. Alright, and this is the Q bar that I'm talking about, is also over here. And then this one is the axial stiffness matrix we have discussed. This is, and so far up till here, alright, all above are only talking about a 1 ply only. Alright, 1 ply. From here onwards, these are all multiply. Alright, meaning a lot of plies, more than 1 ply. So you stack different plies all together. Okay, and this is why you see it's a summation of Q bar. It's a lot of Q bar add together. So this one has its own Q bar, this one also has its own Q bar, this also has its own Q bar, and then you sum them all together. Okay, and then the modulus you can find yourself. Alright, and then this one over here, I think you need to read it up. I don't know what the hell, but I think in the future you might need it. So I think this is somewhat of a summary of all the things that is needed throughout the 2 lessons, lesson 5 and this lesson 6. Okay, so I think this is it for this whole lesson. Then next up is the tutorial. See you.